Now that the flight planning navlog is complete, we need to finish up the performance calculations. The weight and balance would typically be part of this, but because this step has been covered off previously in this course and by your instructor, we won't discuss it here. We first want to find the density altitude. To do this, we need to use the E6b. Align the pressure altitude with the outside air temperature for each airport. First, we will look at Springbank. Using 3,900 feet, we will line it up across from -6 degrees. Now I know the scale is quite small, so do the best you can to get 3,900 and -6. We find that our density altitude is equal to 2,200 feet. This means that our aircraft performs like it's at 2,200 feet. Record this number in your navlog. Using the same method, we find that the density altitude for Red Deer is at 1,300 feet. Record this number in the navlog. Next, we need to determine the length of the runway we intend to take off and land on. You can use additional boxes if you want to calculate multiple runways. For this exercise, we will determine the takeoff distance out of Springbank and the landing distance in Red Deer. Based on the forecast winds of 240, 10 gusting 20 knots, we will calculate the distance for runway 26 at Springbank. The winds at Red Deer were forecast as 150 at 10 knots, so we will use runway 17 there. Take a look at the CFS to find the runway length. At Springbank, we see runway 26 is 3,423 feet long. At Red Deer, runway 17 is listed as 7,500 feet long. Neither of these runways has a 50-foot obstacle at the end, but for training purposes, we will be calculating the numbers for both with and without the obstacle. To calculate the takeoff distance, we need to refer to the POH takeoff distance chart. Be sure that you are referencing the correct chart. In our case, we want to reference the 2,300 pound chart because that is what our planned flight is based on. We also want to make sure that we reference the conditions required in order to achieve the numbers in the chart. We see on this chart that we need to ensure the flaps are up, full throttle is applied prior to brake release, the runway is paved, level, and dry, and there is no wind. If there are deviations to these conditions, we will reference the notes to see how we apply them. Start at the left side of the chart, 2,300 pounds. We see our takeoff speeds referenced here. In our case, we are planning for a 50-foot obstacle, so we would plan to lift off at 52 knots and allow the aircraft to accelerate to 59 knots at 50 feet. The pressure altitude we previously determined was 3,900 feet. This corresponds closest to 4,000, so we will use this line. The temperatures in this chart are only in the positive range. This means that because we have an outside air temperature of -6, we can use the 0-degree section. At 4,000 feet, we see our ground roll is 1,045 feet, and our total to clear the 50-foot obstacle is 1,880 feet. Now let's refer back to the notes to make adjustments. Note 1 says we need to follow the technique specified in section 4. I'll let you reference that on your own if you're flying this model of aircraft. Note 2 says prior to takeoff from fields above 3,000 feet of elevation, the mixture should be leaned to give maximum RPM in a full throttle static run-up. We can do this while we are performing our run-up or on the runway just prior to takeoff. Note 3 says to decrease the distance 10% for each 9 knots of headwind. This actually helps us out. If we had a tailwind, we would need to add distance. Because the forecast called for winds of 10 gusting to 20 knots, we will only use the 10 knots. The reason for this is that more wind equals better performance. If during our takeoff the gust is not present, we want to make sure we can still achieve our performance. Now this boost in performance for a headwind only qualifies for the headwind portion of the total wind. Because the wind is not lined up with the runway, we need to figure out what the headwind component is. Remember that the wind from the METAR or TAF is in degrees true. The runway heading is degrees magnetic. We therefore need to convert the wind direction from true to magnetic before solving for the headwind component. Find the variation of the airport either on the chart or in the ref section under the airport in the CFS. In our case, the CFS says that Springbank is at 15 east. To convert true to magnetic, we subtract. So 240 minus 15 equals 225. Now we can look at the crosswind calculation chart. I'll use the one from the E6B slide. The runway heading, which is found in the runway section of the CFS, says that runway 26 is positioned at 255 degrees. If you don't have access to this information, rounding to the runway number is okay. 255 minus 225 equals 30. This means that the wind is 30 degrees off of the runway. Find where the 30-degree angle line intersects with the 10 knots of total wind curve. Follow straight across to find the headwind component and straight down to find the crosswind component. We see here that the headwind component is about 8 knots and the crosswind component is about 4 knots. Referencing back to the chart, we need to decrease our distance by 10% for each 9 knots of headwind. Do we have 9? No, we don't. Even though we are close, it's best not to take credit for the headwind as it is a safer margin. The only other note remaining discusses operation on a grass runway. We are not doing that today, so we are done. We have determined the ground roll to be 1,045 feet and the total distance to clear a 50-foot obstacle of 1,880 feet. Add these numbers to your nav log. The landing distance chart works the same way. In this aircraft, there is only one chart. Again, read the conditions. We see here that it requires a flaps 40 landing, power off, maximum braking, paved, level, dry runway, and zero wind. 3 notes might apply. Note 1 states that we must follow the manufacturer specified technique. Note 2 details reductions or additions in distance based on wind. And Note 3 talks about reductions for operations on grass runways. The forecast wind showed 150 at 10 knots. Again, we need to convert this to degrees magnetic. The Red Deer Airport shows a variation of 14 east, resulting in a wind direction of 136. The runway direction for runway 17 is 165 degrees. This means that the wind is 29 degrees off the runway. We can round this to 30. Just like before, let's reference the crosswind chart. We find that the headwind component is 8 knots and the crosswind component is 4 knots. As Note 2 dictates, we need 9 knots of headwind to take credit for it. In this case, again, we come up just short, but that's okay. Let's look at the chart. Enter the chart from the left at the 2,300 pound weight. We see that the speed at 50 feet should be 60 knots. Our pressure altitude, as determined previously, was 2,900 feet. And rounding this to 3,000, we find our ground roll to be 550 feet. And our total to clear the 50-foot obstacle is 1,300 feet. You will note that we used the 0-degree column again because we are operating at a temperature below 0. Record these numbers in your nav log. Now looking at the nav log and referencing the takeoff and landing distances, do we have enough runway available? Yes, we do.